All right, welcome to episode 5 of customizing the FPS template in Roblox. And in today's episode, by popular demand, we're going to be making a rocket launcher and creating some effects for that rocket launcher. Someone suggested that when the player shoots the ground, it shoots the player straight up. Fantastic idea. So we're going to be doing that today. We're going to be putting in the explosion and making sure the explosion doesn't hurt the player. So that's going to be very important. There's going to be a lot of scripting today, so really pay attention. Um, Other than that, I already set up a view model. So if you need to set up a view model, watch my previous episodes and you'll have a view model in no time. Now, right now, the view model is just an auto blaster, but we have it all set up, ready to go with the proper attributes that we have. And let's see. Let's just kind of clean this all up here. Now, first things first, I have the tool set up already. We have our aim offset, aim speed, FOV, all ready to go. Now, make this more of a rocket launcher, we're going to need to do a couple things. First things first, the easiest, we need to change fire mode. Change that to semi. And then for ammo, we'll just set this to 1. And then for magazine, we will also set this to 1. And I believe that is it for the already made attributes. Now, we need to make a new attribute. It's going to be like a check for our script. Basically, it's going to be a check to make sure that the tool is the rocket launcher. Okay, so we're going to make a new attribute and we're just going to call it RL. And we're going to make it a Boolean type and save. And then we're going to click this to true. Now, we don't have to add this attribute in any of the other tools. This could be the only tool that has this attribute, RL. Like I said, it's just going to be a check for our script to make sure that this is the attribute. Okay, so just like in any of my other videos, we go inside Blaster or replicate storage. We go into Blaster. We go into our constants. We made a new attribute. We're going to add it here. So we're going to say rocket launcher equals, and then just like how we spelled it, RL. And that should be it for our constants. And we're basically done with replicated storage here. Now, I made a video in the past, maybe like a couple months ago, of adding custom effects and like a custom explosion, that sort of thing. Now we're gonna be actually using pretty much the same method, just a little bit different. But we're gonna go inside server script service, inside Blaster, inside the scripts folder, and then inside our um, Blaster script. And this is where everything's gonna be happening. So first things first, we actually need to make a new function. So we're gonna make some space, and we're gonna create a new local function, and we're just gonna call it rocket launcher. And we're going to need the position and the player. Now, the position is going to be very important because in this script, they're using rays and the ray result, and we're going to be using the result position. And we're going to pass the result to our rocket launcher, so it knows because we're going to be making a couple instances, a couple parts, that sort of thing. So and those things need positions. So that's why we're going to be passing position to it. So, like I said, we're going to be making a couple instances, some parts. So that's going to be the easiest thing to do. We're just going to say local part equals instance.new. And we're just going to create a new part. And we're going to say part.parent. And we're going to parent that to the workspace. Then we can say part dot size equals vector3.new. And we'll make it relatively big for now. We'll say 5 by 5. Okay. Now we could say part dot position equals position. And then just for testing purposes, we'll say part dot anchored equals true. And yeah, that should do it. Now we need something to happen when the part is touched. So we can call a part touched event, and then we can get rid of everything inside here, and we'll just say hit. And then inside this touched event, we can add our explosion. So we can say local explosion equals instance.new. We're going to create a new explosion. Now, Roblox has documentation on explosions. If you really want to deep dive into it and find, all the ins and outs of it, I suggest reading it. But now we can mess with the settings of explosion. So we could say explosion parent equals workspace explosion dot position equals our part dot position, and then we can say explosion dot blast radius equals 10. We can always reduce this if need be, but 10's a pretty good number. And then we can say explosion dot blast pressure equals 0. Now, the blast pressure being 0 is very important, especially if we don't want to kill the player. So, if the blast pressure is even remotely above 0, it will kill the player. So that's why we're gonna keep it at 0 and make sure that it doesn't kill the player. So now we need something for when an explosion hits something. So we can say explosion dot hit colon connect function, and then we can get rid of all this in here and say hit. Now we're gonna need humanoids, so we're gonna say local humanoid equals hit dot parent find first child of class humanoid, and then we can say if humanoid and hit dot parent dot name doesn't equal uh, player dot name, then we can say humanoid colon take damage 100, and that should do it for the explosion. And we'll find the end of this. And now we need to take care of for when the player shoots at the ground. We want the player to go up. So we're going to be using something called linear velocity. And linear velocity is actually very cool to use. It has a lot of features. And if you ever use body velocity, this is a better version of body velocity. If you want an easier method, even though it's depreciated, body velocity is still valid. It's just less control. But I like to have control over everything, so I'm going to be using linear velocity today. So to make this all work, we're going to need a couple things. We're going to need the player root part, and we're going to make that equal to player dot character dot humanoid root part, and we're also going to need the the root part attachment. Now, linear velocity uses attachments to make the make it all work. So we just come in here real quick. We'll make a rig real quick, make a block. Now we can always create a new attachment inside the player. The thing is with linear velocity, we have to destroy it after a amount of time, or else the player will just keep having linear velocity. and we'll just keep floating up and up and up in the air. So you could make another attachment. The thing is, it'll keep creating an attachment. So we would also need to clean up the attachment. So that's why we're going to be using. If we go inside the rig here, we'll go inside the humanoid root part. We're actually going to use the root attachment that's already inside the humanoid root part, just so it's going to be a little, just so that's going to be more clean inside the script. So we need to call our root attachment, and that's going to be equal to our player root part. And we're going to say find first child root attachment. Make sure it's spelled correctly. And then we could say local linear velocity equals instance dot new linear velocity. And then we can say local force direction equals vector3 dot new. And this is where we're going to be applying our force. We don't need anything on the X, and being that we want to go straight up, we're going to need something on the Y. So we're going to say 100 just for now. And you can mess with these values. Don't be afraid to. I'll do a few examples of just messing around with these. Now we can get into, we can say linear velocity dot parent equals player root part, and then we can say linear velocity dot attachment 0 equals root attachment, and then we can say linear velocity dot max force equals math dot huge, and we can say linear velocity dot, actually, yeah, let's do that, equals enum dot velocity constraint mode dot vector. Now in the documentation, I believe that vector is default, but just in case, we're just going to set it here. And then we can say vector velocity equals our force direction. Now, like I said before, now we have to clean up the linear velocity, or else it'll just be inside the player and we'll just keep floating and floating. So we're actually going to get service. We're going to say, actually, before we do anything, we're going to say if hit dot parent equals player dot character. Oops. Dot character. Then here. Now we can say game colon get service debris, and then we can add item, and then we'll just add our linear velocity, and then we'll give it a lifetime of 1 second. Now we actually need to do the same thing for our part, so it doesn't just stay in the workspace and just keep exploding. So we're just going to come down here and say game colon get service debris, and then we're going to add item, and then we're going to add our part, and then we'll just give this a shorter lifetime. We'll say half a second here, and I believe that's it for our function. Now we need to tie it all together for our rave results. So we're going to come down here. We'll say right here, we'll say if ray result dot tagged humanoid and blaster colon get attribute And then we can call our new constant dot rocket launcher. And then we want to make sure that equals true. So we're going to say equals true. Then we can call our new function. And now we're going to pass the position and then the player. So we're going to say ray result dot position and then player. Now I believe we also have to come down here where force is for the instance. And basically the same thing as above. We could say if ray result dot instance and ray result dot position, then we could say if blaster colon get attribute constants dot rocket launcher equals true, then call our function, and then we pass ray result dot position and then pass player to it. And yeah, I think that's basically it. Let's test this out. We create our part. It explodes. Now, why it's not exploding on them is because we have our anchored. Now, we're just going to keep this here, but we're just going to say false. And now it should explode anyway. And let's see what happens when we shoot the ground. And we float up in the air. Easy as that. Now, I did say before, let me show you what happens when we don't destroy this linear velocity. So we're just going to toggle this out. And then we'll press play. Now, we should just keep floating. And if we look inside our player, you will see that we have all this linear velocity. So that's why we have to destroy it, or else we'll just keep floating and floating and floating. Let's do that. Let's get this back in here. And like I said, you can mess around with the lifetime. Like say it's like 5 seconds. Like we'll float for like 5 seconds. And we should be coming back down. And let's say, you like the amount of time. Oops. You can also mess with the direction. We'll say 200. Easy as that. But I think what we'll do is just keep it at 100 for now. And we also need to make the part smaller. Because if we press play, we'll have like a range. So it explodes there, explodes there, explodes there. So every time we touch, why this is working is because every time we touch this part, it's going to give us that linear velocity. So it's not when we are shooting at the ground and that it knows that we're looking down. That's not the approach we're taking. So we want a more look down approach. So, and to do that, we need to make this part smaller. So if we make the part smaller, we can right about there. It's almost completely looked down. It's like right here. I can't go any further, so it's like right there. That's not too bad. We can always make it smaller and make sure that we are looking straight down for it to apply the linear velocity, but that's pretty good for now. Um, Now we could just make this part invisible. We can say part dot transparency equals 1. And let's say you want to make a sound for our explosion. That's easy as well. We could say we just make a new instance. We say local sound equals instance dot new, and we can say sound, and then we can say sound dot parent equals workspace. Now we could parent it to the part itself. The problem is that if multiple explosions happen at the same time, the sound on top of it will like double play, and we don't want that. So just in case there's like a double explosion, um, because I believe that if the part touches multiple players, that it'll kind of duplicate. So, and we don't want to duplicate the sound. So that's why we're going to parent it to the workspace. We're going to say sound dot sound ID equals this for now, just to keep it empty. Sound dot um, actually we could just say sound colon play, and then we can say sound dot ended colon connect function. We can say sound colon destroy. So every time this function is called, it's going to create the sound, it's going to play it. Once it's ended, it'll destroy the sound. It'll just keep looping. So I'm going to fast forward real quick and get a sound that will sound okay. Okay, so I found a sound of an explosion that sounds pretty good. So we're going to try it out. Yep. I'm going to duplicate. And if we shoot at the ground, we float. And I think that's going to do it. Yeah, if you liked the video, like, comment, subscribe, and I'll catch you guys in the next one.